Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides additional practice in performing hypothesis testing and constructing confidence interval estimates for two independent population means. Let's get started. So let's look at a little bit of the battle of the sexes here. So we've got a table here at the bottom of the screen showing us the sample sizes for a group of men and women. And what we're doing is we're tabulating the average number of words that are spoken per day by men and women. So that's what our X bar is, the average number of words spoken per day. And then the sample standard deviation you can see down there below. So we're asked to answer the same stock questions that we're used to seeing with our hypothesis testing. We're using a 1% significance level. And the claim is that men speak fewer words per day on average than women. I'll let you decide whether it was a man or a woman who came up with this claim. I'm just going to say I had no part in it. Okay, I'm taking this from somewhere else. So I'll let you decide, was it a man who said this or was it a woman? So our first question was about our hypotheses, and as always, when forming our hypotheses, we're going to think about the claim that's being made. So what's the claim being made here? Well, the claim is that men speak fewer words per day on average. So the men were mentioned first in the problem statement, so that's going to be mu1. The women are then going to be mu2. So we have mu1 is less than mu2, or the alternative way of writing it, mu1 minus mu2 is less than 0. Our null hypothesis, as always, a statement of equality. So we can write that out here. And the alternative hypothesis typically reflects the claim. There's no semblance of equality with our claim. So therefore, we're just going to adopt that as our alternative hypothesis. And that inequality sign that we have here is like an arrow pointing to the left. So that means we have a one-tailed test on the left side of the distribution. The next question we were asked was about the test statistic. We can calculate the test statistic old school style, but let's join the 21st century and use Statcrunch. So in Statcrunch, we're going to go to Stat, T-Stats, because we're going to use the student T-distribution, two samples, because we've got two samples, with summary, because we don't have actual data, just summary stats. In the options window, we're going to enter in our information. Again, remembering to leave that pooled variances box unchecked. And once we get everything in, we press compute, and then we get this wonderful results table coming out. And of course, the test statistic is going to be that second to last value there in the table. The p-value is, as always, going to be found as the last value there in that table. So now we've got the numbers that we need to actually go through and conduct the actual hypothesis test. So, will we reject the null hypothesis or fail to reject it? Well, it's going to be the same criteria that we've always seen. If we're outside the region of rejection, we fail to reject. If we're inside, then we reject. Here's again the results that we got from our hypothesis testing calculations in Statcrunch. If we use the p-value, which is the number there on the end, we'll compare that with the significance level. We find that we're well above the significance level. Therefore, we're outside the region of rejection, and therefore we fail to reject the null hypothesis. Alternatively, we wanted to use the test statistic. Okay, notice that negative 0.6755 puts us somewhere around here. That's outside our critical region, which is our region of rejection, and therefore we're going to fail to reject the null hypothesis. What do we conclude from the hypothesis test? Well, we know the pattern here, so did we reject or fail to reject the null hypothesis? We were outside the region of rejection, So we failed to reject the null hypothesis. Therefore, there is not sufficient evidence. We have a one-tailed test, and therefore we're going to support the claim. So the answer option that we want that gives us those options is answer option B. Again, note where each part of this statement comes from. We failed to reject the null hypothesis, so there's not sufficient evidence. We have a one-tailed test, so we're going to support the claim, and then the rest of the statement is just a restatement of the claim itself. What is the appropriate confidence interval? Notice they don't tell you what level to conduct it at. They just say appropriate level. They're hoping to trip you up on, calculating that confidence level. But we're not fooled. We understand what's going on here. It's going to be 1 minus 2 alpha. So in our, going back to our options window, we just click this radio button from hypothesis testing down to confidence interval, and we're going to put in 1 minus 2 alpha for our confidence level. So alpha is 1%, so we subtract 2% from 1 and get 98% for our confidence level. Then we press compute, and out comes our results, the lower and upper limits for our confidence interval estimate there at the end of the table. And it's really no more complicated than that. It's pretty straightforward stuff here. Now, the last question. What do you conclude from these results? Well, what do we conclude from these results? The question we need to ask when we're dealing with these confidence intervals is 0 inside or outside the confidence interval? Look at your confidence interval limits right here. Is 0 inside or outside? It's inside. Therefore, it's possible that the difference between the mean values could be 0. And if the difference is 0, that means they're the same. They're no different. So, because our confidence interval contains the value of 0, we're going to conclude there's no difference between the average number of words spoken by men and women. This idea that one gender speaks more than the other, seems to be a little sexist here. However, remember, CIs on means are just as reliable as our formal hypothesis testing methods. So we're going to get the same result. There's insufficient evidence to support the claim that men speak less than women. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.